Welcome to Never Rewrite. I'm Isaac Askew.
And I'm Jeffrey Sherman. And today we're joined by Rob Gonnella to discuss the never rewrite concept from a DevOps point of view. Rob, welcome to the show. Thank you so much for coming on.
Thanks for having me.
So like I said in the intro, my understanding is you do DevOps fairly exclusively, and you...
Yeah, I bounce back and forth between being a DevOps engineer and a back-end engineer.
Okay, good. Let's not talk about those dirty front-end people. Oh, hi, Isaac.
What? I'm full stack. Anything.
You're the most front-end engineer here.
Fair.
So how does the genesis of this episode, we were talking and sort of the idea of, oh, well, what do, in the DevOps world, so much of it is set up and tear down. Do you rewrite, like, I imagine Terraform, you probably don't rewrite your Terraform scripts, but on the flip side, when you publish it, I think it just throws the whole thing away and builds a new one, right?
Yeah, well, so this kind of gets into the concept of what is a rewrite in DevOps world, right? Is a rewrite, changing the underlying infrastructure? Say you have something deployed to Elastic Beanstalk, and you say, well, that was good for the prototype, but now we need to move it to EKS. Is that considered a rewrite in DevOps? I would generally say no. I would consider a rewrite in DevOps being like, oh, we wrote all of our infrastructure in Terraform, and now we decided we want to use Pulumi, and we're going to rewrite the whole IAC in a different, DSL or whatever it is, using a different tool. And the reason I say that is, changing underlying infrastructure for a service, generally, if you want to move something, say, from Elastic Beanstalk to EKS, as an example, a single DevOps engineer could probably handle that over the course of a week, including whatever devs they have to pull in for manual testing, for a single service or something like that. So that stuff is more common and is less risky, especially with well-tested code. But if you were to actually rewrite the underlying tool and go from Pulumi to Terraform or Terraform to Pulumi, whatever it is, that comes with a lot more risk and can be pretty hairy.
Interesting. So one of the guidelines that Isaac and I have been working towards for, what is a rewrite versus what we've been calling thesis shipping, where we're iteratively delivering, is when you have a rewrite, you essentially have two of them running. You theoretically have two of them running in parallel, and you're going to cut over, you've got one, and then the next day you're going to cut over, you're going to run your infrastructure on the other.
Yep.
Whereas if you're changing iteratively, you've never got more than one release worth of stuff that's not out and tested. So if you were to change from Beanstalk to EKS, is that a hard cutover, or can you make those changes iteratively, or is that you still have a hard cutover at some point?
No, you'd wind up having a hard cutover, and you would, the holy grail of DevOps is zero downtime, right? So generally you want to stand up instances alongside other instances in parallel and do a cutover, because that's how you get zero downtime, or one of the ways you get zero downtime. So that's a good thing in the DevOps world. Otherwise you're stuck with trying to manage a single instance, and then if something goes wrong, you have no fast way to cut back, or roll back rather.
Interesting. Yeah. So that's a good call out about the difference, where in the software world, if you've got two systems running in parallel, really you can only use one. But in the infrastructure world, if you've got two systems running in parallel, you could theoretically move your stuff between them to mitigate risk.
Yeah, and in fact, I mean, throughout DevOps and the infrastructure world, like having redundancy and scalability is all about having multiple, you scale horizontally rather than vertically. That's sort of the microsystem or microservice architecture, right? We can add more compute nodes rather than scaling up actual RAM and CPU in a single instance. sort of that distributed system that makes it great. And with that, you get a whole bunch of the ability to do these like blue-green deployments where, you stand up a new, with EKS, you roll out services in parallel and then kill the old services when the new services are up and active, or even canary deployments where you're deploying something in parallel that is going to get a percentage of the traffic so that you can test out how that's going to make sure that there's nothing horrible. If anything horrible goes wrong, it only affects a certain percentage of users, and then you can roll back easily.
Right. I feel like the software world has somewhat taken that on with the idea of feature flags and slowly shifting the thing. But there you've got all of the stuff is in the software. It's just you're using the config to go down different paths.
Yeah, and with the DevOps, you're talking about network traffic.
Right. From going back to the original example, Elastic Beanstalk to EKS versus Pulumi. If you rewrote everything, with Pulumi being the rewrite option, and you stood up the same thing, is there a difference in how you would cut over between the old and the new in that scenario?
Not a whole lot of difference, just a lot more of it, and a lot more areas for there to be errors. And you would still want to stand everything up in parallel, and you'd still want to have a big cutover. But again, if we're talking about the rewrite in the context that you guys have been talking about, which is like, we're going to build it all at once. We're not going to do it iteratively. We're going to try to just stand up the entire infrastructure, for the entire company. That would be
we put all the databases out,
right. And then try to
set insane.
Right. So you could it would make way more sense to do that iteratively and say, okay, we want to switch to Pulumi, so we're going to take this service here and change its infrastructure to Pulumi for just this one thing and just keep doing that until you get everything over. But to do a full rewrite like that would not iteratively would be really, really challenging.
Yeah, I imagine you get the data migration, if nothing else, would be extremely difficult.
Data migration and the order of cutover, because now you're talking about the entire company's infrastructure, or maybe even it's just a subset. But even with a subset, what things depend on other things, and what order do they need to be cut over? If it's true microservice architecture, a lot of times things should be able to stand on their own without those dependencies. But let's be honest, how often do we encounter really, truly microservice architecture where there's no dependencies like that?
I think I've seen it a couple times.
Yeah, it happens, and it's great, but it comes with a different set of complexities.
Yes. Tracing things becomes so complex. Okay. So we've got the idea that you just generally don't. Would it be fair to say that in DevOps world, doing a full rewrite with the idea of I'm going to stand up all the new infrastructure and then do a hard cutover, is that something that just people don't propose because it sounds so insane? Like, no, it's got to be, one service at a time? Or
yeah, I've never seen that attempted. I mean, maybe if you are at the beginning, again, we're talking about maybe a subset of the infrastructure for a company, and maybe it's a new greenfield project that isn't even live yet, and you want to say, oh crap, we want to move it all over to the stuff, and none of this really matters, so we're just gonna nothing's live yet. So yeah, sure, in those cases.
Okay.
I feel like that's exempt from the rewrite status.
Yeah, right.
Yeah, I don't know if you're not in production, I don't know that you can qualify as a rewrite.
Right, exactly. Yeah,
I think we've spent at least 3 episodes describing what we mean by rewriting.
Yeah.
So we have to have a good definition of that.
But for anything that's live, yeah, I wouldn't do a rewrite in that sense in the DevOps world. Trying to think if there's There was one time I encountered two different Terraform repositories. So we had IAC stored in two different places. One of them, sort of the directory structure was kind of older and set up by somebody who wasn't a DevOps person, and it was becoming a pain to maintain it. So I had to migrate, or I chose to migrate their Terraform code over into our newer Terraform repository that was nice and ran fast and had all the bells and whistles that we like. And that was a little, it was a little dodgy in that, you know, you have Terraform state for real infrastructure that are stored in, you know, we have to get it out of one state file and into another. But we don't want to actually change any of the infrastructure. We just want to rewrite or change the location of the code. And that wound up being tricky, but was still done iteratively. As in, you take a single piece of infrastructure from the other state, move it one piece at a time over to a new state file, and then basically get rid of the old, you know, remove it from the old state file also, so that Terraform doesn't know about it and actually accidentally delete your infrastructure on the next run of the old repository.
That never happened to you, I'm sure.
No, luckily not in production.
And staging.
Oh yeah, so that's
That
why
never
we
happened
have,
to me in production.
why we have you know, even before staging, you know, some dev accounts or some test accounts where you can, what's really going to happen when I run this? And then of course you always have like some safeguards in Terraform or something like that, where it's like, you know, under no circumstances should Terraform ever delete this database, you know.
Those would be nice safeguards in the software world.
Yeah.
You can add them. They just look a little different. So
they're not baked in.
Rob, it sounded like you had kind of an example for us for the show. That's like a time in which you might want to, like an exception where you might want to rewrite.
Yeah.
Can you tell us a little bit about that?
To every rule, there is potentially an exception, right? So I was thinking about this, and something that I have encountered and am currently dealing with right now. Essentially, a request came in to build a product, essentially initially as a POC, just a proof of concept. We're going to try it out with this one partner, and it's a simple design where we're going to take some unstructured data from this partner, and we're going to parse it into structured data, and then we're going to fire off, we're going to set up a queue system that processes workloads as jobs. And initially, these jobs don't need to be aware of each other. They just need to take in data, do their processing, go, right? Pretty simple. We set it up, we get going with this partner. It's going great. Now, again, still supposed to be a POC, but now we have a partner running in production who's enjoying the use of this product. So, you know, product steps in and sales steps in and goes, that's going great. I want to shop this. So now we start getting more partners interested and involved. And we get their unstructured data, but their unstructured data is obviously different. So we've got to handle that. But more importantly, they have different requirements than the first partner. And they say, let's say the next partner goes, well, that's cool, but I want my jobs when they fire off to do something slightly different based on some configuration that I'm going to give you that's going to be specific to us. And you look at it, okay, so we've got to store some data about a partner, and we've, you know, put a partner ID in the jobs and let the jobs pull the config and make some decisions within the job. Okay, cool. Everything's running cool. That partner's happy. Product and sales is happy, and now they're getting more partners. Next partner comes in and goes, yeah, I want to change, you know, I want jobs to be conditional based on other jobs that have that are either already in the queue or you know, state of previously finished jobs. And you go, oh crap, We didn't
Okay, now you
design.
need a full stateful job server.
Right, exactly. So now we need a database, and we
No.
need, we need to store some data, and we need to have some state, right?
Yes.
So we start building that out, and we say, okay, let's, follow KISS principle. We only have one partner who needs this right now, so let's do the least amount that we can to make this partner happy and roll it out, because
Mhm.
their product wants us fast because they want to sign this partner. And so you roll it out, and you can see where this is going. As you get more and more partners, these requirements start getting really, really dodgy, and then you start taking a step back from the system that you've built, and you go, well, crap, this POC is not, it wasn't designed to handle all of these requirements, because we didn't know what the requirements were at the beginning.
Mhm.
So now we have to step back from it, and we say, okay, there are a couple of key things that we might want to change. One of the things that we came across was that we found a lot of the data wound up being highly relational, and a lot of the state wound up being highly relational. And we had kind of an initial system, after getting a bunch of requirements, we wound up having a DynamoDB at the beginning that just kind of handled some data that we wanted to store initially just for tracking, but then we wound up with another table and another table, right? And we started to look at and go, okay, this would have been much better had we chosen, something like Postgres or some relational database at the start.
Mhm.
Well, pulling out the database from a system like this, as you start to follow that path down, it starts to look a lot like a rewrite. And we looked at it and we said, okay, we could try to do this iteratively, and it would be a giant pain. Luckily we did follow like a hexagonal architecture, so all dependency injection, we could just inject interfaces wherever we need them, replace them as needed. But we found that the underlying data structure was going to be different enough that this project was now only 4, maybe 5 months in. It wasn't a huge project yet. We looked at it and we said, I think we can just stand up a Postgres database, kind of rebuild some of this in parallel while we're continuing on with some of existing partner needs. And most importantly, we found a specific feature where we're like, this is going to be so much easier to implement in the new design that we can use that as the cutover catalyst, if you will. So before we get to that in the old, we're not going to bother trying to implement this in the old. We're just going to use this as the time where we cut over.
Let me see if I can rephrase and summarize. You have a organically growing product that you realize you've got some fundamental, now that you're into it, you've got a fundamental mismatch in the database, basically.
Yep.
And so you need to rewrite the data model. And in this case, we're talking about a product that is less than 6 months old, so it doesn't have a huge amount of history.
Yep.
All the original developers are still there.
Yep.
Or pretty much the original people who built the thing know what it is and what it does.
Yep.
You've got a good design. Would you say that you've also got good unit test coverage and all that?
Yeah, great unit test coverage.
Okay, so you actually understand the functionality.
Yep.
And you have a use case. You have a valuable use case for the new version that doesn't exist on the old version.
Yes.
Okay. So, and your plan is to build the new case first, right? And build as much as you need to. Well, let me ask you. So, what's your plan for rebuilding or building?
The plan was, and we're a ways into it now, is to actually get parity with current features, which again, there's not a lot. And then to finally add this last piece, which we're basically at that point now. And so we're probably going to be working on the cutover, I would say, within the next month.
Interesting. And how long did you expect it to get to parity, and how long has it taken you so far?
As always, it takes longer than you expect,
Mm.
even with something small like this. You know, the data model wound up, the relational aspects of it wound up being a lot more complicated than I expected. But we also intentionally wanted to improve in certain areas where we could.
Mm-hmm.
So it did get more complex in the data model, but for a good purpose. And I would say, I think it's only been maybe 2 months tops of us doing this rewrite, and we're getting ready to cut over within the next month.
So when you said the original project is only like 4 months old, does that mean you started the rewrite when it was 2 months old? Or that it was 4 months old and now it's like 6 months old?
Yeah, I think it's 6 months old now. Yeah.
Okay.
Yeah, at the time we decided to do the write, it was probably 4 months.
And so you've been holding off on this one new feature that you said you need the improved data model. Has there been other features that you put on hold?
No, there's nothing else that we put on hold. There was one other feature that started the discussion for this rewrite. And we were able to basically duct tape together a version of this feature that works in the old system.
Mm-hmm.
But it was the thing that started the conversation that said, maybe we should look at our initial design of this and consider rewriting this with like a relational database. And that feature in and of itself was just supported out of the box in the rewrite.
Interesting. And then I'm so curious, so I'm going to keep probing you. So just let me know if I'm asking too many questions.
I don't know. Go hit me.
So the description of it, it's a queuing work queue system plus jobs, and the jobs seem like they're moderately distinct per customer. And then you've got the rewrite version that you're cutting over to, does that use the same queuing system, or is the queuing system agnostic to the version of the jobs?
Yeah, so parts of it are. Ultimately, there will still be a queuing system of some kind. Actually, there'll still be the queuing system, that we have today will be reused. The difference will be in how things are sort of batched at the beginning, how the processing or the pre-processing, if you will, of the stuff that's going to wind up in the queue, how all of that stuff happens, is going to be very different.
Interesting. So the queue is mostly the same, and I guess let me rephrase the question so that I can emphasize what I'm going for. Will at some point the same queuing system with you'll have a preprocessor and then the queue and then the worker jobs. Will the old and the new worker jobs and the queue commingle at the same time for some period of time? Or will there just be a new queuing system running new jobs and an old queuing system running old jobs that will exist in parallel for some time?
Yeah, no. So I think they're actually going to run in parallel. In fact, I think we're going to use the existing, some of the existing code and queuing system to update the new database at the same time as, so it'll stand up in parallel, and basically both will receive events, and one will start updating the new database and the other one will follow the old path, but we'll start getting all of the new data and everything in the new system. And it'll even go through, sort of a mock, like the final stage where you would actually do the work. It's going to do that, but without actually producing an actual result. We'll leave the old system producing the result. The new system will just act like it produced the result and update the database so that we can kind of do a bit of comparison to make sure, hey, the new system is operating in a similar fashion as the old system. And then there'll be the cutover that says, okay, turn off the old one and let the new one's results actually be real.
Interesting.
Does that make sense?
It makes sense. And so I just want to summarize because I think we got off topic because my curiosity got us off topic into a tangent. You're making the argument that, hey, here's a case where it's the same team that built the system, right? We built the system and we very quickly realized we did it wrong and we want to rebuild it from scratch. And it's the same team, it's a very small amount of code, and we understand it because we built tests and up as we went along, so we can actually prove, theoretically, we can reuse the tests and prove the business logic again. And so there would be a case to rewrite.
Yeah, that's my argument in a nutshell. Yeah. Except that we didn't do it wrong. We just didn't have all the requirements up front.
Fair enough. Yeah, I would argue that most people who've gotten themselves into these organic messes, everything they did made sense because they didn't know what the future held when they started.
Yeah, exactly. And actually, it's a good distinction. I know a lot of your podcasts talk about, or a lot of other episodes talk about how, don't get mad at the old developers. They were working on the information that they had at the time, and there's a reason it was built the way it was built. Not it's not just that every developer is terrible and you're great. That's not the case. And this is a good example of we built something with the requirements we had at the time, and then we stepped back after getting more and more information and more data and more partners, and we went, okay, well, we built a system that doesn't fit the new set of requirements.
Right. And that's totally fine and normal. I think the part that catches in my head from the description is, the data model, you wanted to make improvements, and so it became more complex.
Yeah.
And so it's taking you you were 4 months in when you started the rewrite, and then it took you 2 months. So it's like it took you 50% as long to rewrite it as it took you to build organically build the thing.
And I'll say this because it's there is something to be mentioned there. Because it is a small project, the rewrite has only been 2 developers working on it. And we also have other responsibilities and other tasks. So that 2 months, had we been both full-time on it, and even given more resources, like it could have been done probably in half the time.
Yeah, it's probably always, well, not always the case. Many times you get lots and lots of developers and lots of resources, and then you proceed to make a mess because you've got so much talent. But that's
so do we have another exception here where it's like never rewrite unless your proof of concepts that you were just messing around with took off, and then maybe you should?
I'm not sure that we have a new case, because I think it follows sort of some of the original cases, which is you've got the wrong technology, like you fundamentally have the wrong technology, and you understand what the system does, which is one of the main things about the rewrite is you can't rewrite until you know what the system does, and you know what your system does.
And in this case, nobody's looking at the code, the existing code, and saying, oh, this was bad. Like, this is really, really bad. Who wrote this? This is terrible. They're just looking at it and going, crap, we have a mismatch of system design and requirements.
Right.
Yeah, I think that is a wonderful thing to call out, that the code is good.
Right.
And you are the old developer. Like the rewriting developers are the old developers, and the code itself is good. It's just happened to be the wrong. The problem wasn't what you originally thought it was.
Exactly. Yeah, that's exactly it.
Yeah, a lot of the old cases that we've mentioned in like he's getting at in our old podcast is like usually the developers are no longer there at the company at all. The code could be like a decade old, and already been live in production. These are it's almost like rewriting proven products rather than this case, which is a very fresh one. So it is an interesting distinction for sure.
Yeah, and in those cases, how easy is it to get to a code base that you perceive as quote unquote bad,
Mm.
be able to say, well, I don't want to take the time to understand this spaghetti code. Just let me rewrite it.
Oh, that's the easy.
And
Yeah,
that would be a
stuff.
disaster.
Yeah,
Yeah.
right. Here we've got a case where, and I think that there's a third point that we didn't hit on, which I think applies here as well, is there aren't a huge list of features that you need to get done, right? So there's no development going on the product while you're trying to rewrite it in the background. It's the product.
There is a bit.
Oh, okay.
There is a bit, but like I said, we have the catalyst feature where it's like, okay, you can develop up to this point, but at this point, you're going to want to cut over to the new system because the cost of implementing this one specific feature in the old system would take you too much time anyway.
Yeah, so I think that's an important call out too, is that there's a feature reason, and that you have some, but not a ton of pressure of maintenance work.
Yeah,
I think that's one of the things that kills you in a rewrite, traditional rewrite, is you've got a team that's continually doing updates, especially bug fixes, and that if you don't, if you didn't understand the system going in and you were just like, I'm going to confidently rewrite it based on the business people's understanding of what the system is.
and I'll call out, even in this example,
Mm-hmm.
I have had meetings with the other developer that's doing the rewrite with me to say, out of concern, to say, hey, how do we keep this from getting away from us, where they keep adding features to the old design and we can't keep up? Because that was a concern. And that's where we found the feature, like, okay, well, here's the feature that's going to get us to the new system. And I think that's
something that you just can't do in the old.
I think it's hugely, if that feature wasn't there, I would still be concerned that we would never catch up, even in a project like this where it's small and it seems to make sense, but
Never rewrite unless it can be done in less than 2 months.
yeah.
Yeah, but that's a confidence issue. That's not.
Yeah. No, I think it's a great point that you made, that like the original developers are all there and everybody understands how it works, and like there's sort of no surprises. We went into the rewrite knowing exactly what was going to happen, what needed to happen, and we haven't encountered anything where we're like, oh, we didn't see that coming.
We didn't know that client even existed.
Right, exactly.
All right.
Awesome. Well, I think it's a good place to wrap it up. Rob, if people want to learn more about you and see some of the stuff that you've been working on, do you have a place you can send them?
Yeah, as always, go to my GitHub. I'm always building stuff and tinkering around. Always be building.
Always be building. We'll put a link to it in the show notes, but what is your GitHub?
Yeah, it's just Rob Gonnella.
Easy peasy.
Yep.
Very nice.
Ella. And lately I've got a couple things in the works. I've been working on a network scanner in Golang. Sort of born out of a pet project that was using Nmap under the hood, and then found Nmap to be a bit slow and just didn't work well in Golang the way I wanted. So I wound up building my own. Obviously I didn't rewrite all of Nmap because that would be nuts. But I took the pieces I needed and rewrote them in Golang.
That sounds very cool. I'm sure I'll not understand any of it, but Go is one of those things I'm like, I should probably learn it. It seems like it's very cool.
I enjoy it. It's a lot of fun. It's a fun language to write in. I enjoy it.
Awesome. Well, thank you all for listening. I'm Jeffrey Sherman.
And I'm Isaac Askew, and this is Never Rewrite.